It's gonna be a weird week, but it's fine. Okay, I started recording this as well, by the way. So I know we missed a lot of it, but it's generally this is how you open a binary file. Make sure you add the iOS-based binary. That's the important part. If you don't have iFstream, you also have to do iOS base in, but I just use it in iFstream, so you don't have to do that. But you definitely need the iOS-based binary. Create a value that's the length. So this is 4 bytes, and it's a number. So this 4-byte number is an int. And then you cast the address of that int to a character pointer, and then the number of bytes you're reading in, and that's why you can print that out. For a string, you first have to get the length of the string. So we get the length of the string in an integer, 4 bytes here. And then you create an array that's that length, and then you just pass in the array and that length that you use, and it'll read that much information. You can just use cout to print it. Just the same thing repeated, and then this time the important part is that it's short because it's 2 bytes. And so right here we can see, so there's 7 ships total. For the first ship, so just going through that, it's 18 is the length of this thing. So this is the length of 18. Then 3 is the length of this. I mean, you might think that there's only 2 characters there, so why is it a length of 3? That's because it includes the null terminator. So you guys don't have to think about the null terminator right now, but just conceptually understand that strings end with a null terminator. And that's why you can just print out character pointers like you can there because of that null terminator. Question? So the question was, when you're working through this table, you're going to create a temporary variable that's going to change through a short int byte, depending. So you will have one for loop for going through each ship, and then an internal for loop in there to go through each weapon. But you should have multiple variables to do that with. So it's not just a singular variable because there's different data types in there. I'm just using a singular variable because I don't care if it's stored in anything. I'm just showing you how to do binary IO. When you do it, you'll probably have a ship object, and you can, instead of using random integers, you can use the integer that's the member variable if you wanted to. Or going the other way around, you can use random variables and then pass those into a constructor or something. So that's up to you how you get the information from here to your object, or from your object to here, depending on if you're how you want to construct it at the beginning or at the end of the for loop. But that's up to you. Does that make sense? Okay. Yep. And so the ship's length, meters, shield capacity, warp speed. If it doesn't explicitly say it, then I would say it's an integer. But like right here, it says a float or an integer. So instead of using an integer for these 4 bytes, make sure to use a float. But yeah, any questions about how to read in this file right now? Because I did just generally give a binary overview, but if you have a question that isn't about the binary part, I can also answer that. But I'm not going over it just because right now I'm assuming you can, but still love to have your questions. Okay, cool. So that's reading in all the information. Just like in last lab, I don't care how you store it. With the Legos, you could make an object, you could have a vector, you could have multiple vectors. I don't care. Store it however you'd like. And then once you've got it all stored, now you're done with the binary file IO part. Once you've read it and gotten the information, that's the hard part out of the way. But you now have to read through all the ships and either print all the ships, print the starship with the most powerful weapon, or whatever else this menu has here for you. So I can like zoom in a little bit. So you'll have to implement these options. And so that's why, again, just like last time, it's important the type of data structure you use, but I don't care which one you use. As long as it makes sense to you and you could do all of these searches, that's the important part. One of the weird things about this one now is that there's objects within objects. Like I'd highly recommend having a ship object and a weapon object, and your ship object has a vector of weapons. If you like to do that, you can. If you don't want to, that's fine. I did see one person in my time as TAing who made a singular vector with all of their weapons. And then in each ship, it just had a count of the number of weapons. And they did some shenanigans with the count in each ship to find the weapon in that singular vector. I couldn't really figure out why they decided to do that, but they did. They got the points. I don't care, like I said. But as long as it makes sense to you, that's the really important part. So again, yeah, using that, make sure you can like read through this, and so whatever way you're using to store that information can be easily used to do this stuff. Because like printing the starship with the most powerful weapon, you need to iterate through every starship, but then every weapon in every starship to locate the most powerful weapon in all of the starships. Just like whichever starship has the most powerful weapon, you need to print that out. So it's like that's more unique than the Lego ones. It's not just going through each object, it's going through each object inside of each object. Cool. Yeah. That's that lab. Any unique part about the tips? So yeah, again, just like last time, figure out what data structure you want to use. It's very important for you later. So yeah, if doing the binary file IO part, if you do that correctly, if you do that in an efficient way, it'll make everything else easier. You're passing vectors around, pass them by reference, so it's not passing a ton of information, though this isn't as important as the Lego lab, just because the Lego one literally had thousands of Lego sets. This one, it's only 18 vehicles, 18 ships, so it's not that bad. So then, just like I talked you through right there, try reading one element at a time. Read the first 4 bytes, see if that is a valid piece of information. 18 is a good number there. I think for enemy ships, it's 7, so we can just change this from friendly ships to enemy ships and run it. Oh, well, something went wrong because that's. Does this still friendly ships? I'm not writing, I'm just reading. Yeah, so 7 for friendly ships, but why was enemy ships? So that didn't seem right. Maybe it is. Oh, I totally moved stuff around, didn't I? Oh no, but it should be Kremlin Warbird. Ooh, so I did something wrong. Oh no, okay, that was something we were at the program. I don't know what's going on there, but yeah, this code still works. Cool. And yeah, 5 for enemy ships, that's reasonable. And then 7 for friendly ships. Okay. If there's no questions on lab 5, I'm going to go over the quiz study guide, and then we're going to hop back to project 2, which is also binary file IO. So just let that sit in your brain for a little bit as we go over inheritance. Okay. So there. No, I just need this. Yes, this and this. There, cool. So I'm going to cut. There we go. So inheritance. You've done inheritance in Java before, yeah? But the keywords are different. I can't give like a reason why they did it differently, just because they wanted to implement inheritance differently. It's probably good enough, but it's definitely different. Or at least we're definitely going into more stuff. So generally what is inheritance is the same. You inherit stuff to make objects related to each other. So a big example is like vehicle and then plane and car. So a plane is a vehicle and a car is a vehicle. And so you can make a vehicle class that's like age, model, number of seats or something like that. And that would be inherited by a vehicle and plane because both of those have an age, model, and number of seats. But then a plane has like wing length and a car has like engine power, horsepower, or something like that. So they can have their own unique stuff, but they're still related by that vehicle class. And really why we do that is to just shorten the amount of code we have to write. Because you could make each individual one separate and have them be their own thing, but it would take longer to write that for everything. Also, if you're dealing with like vectors and stuff, if you wanted to store a vector of vehicle objects that could be either a plane or a car, you would do that through inheritance. There wouldn't be a way if they were completely separate classes to do that easily. You could just do objects because everything inherits objects, but that'd be a little weird. So what names do we use for the two classes involved in inheritance? That's probably like, I bet he put that specifically in his file. So I'm gonna go check that out real quick. I'm gonna assume it's private and public though. Let me go look.
I think it is because he said we're not using protected.
Yeah, that would make sense. I talked about that, duplicate code, inheritance requirements. Oh, it's the big two. Okay, got it. That I told the last. Oh, that's fine. I couldn't access that before. So, there we go. So what he's saying by what are the names of the two classes involved in inheritance? It's like anytime you do inheritance, there's the class that you wrote originally vehicle, and then the class like airplane or car that inherits that. So the two classes that are involved, what he calls them is base and derived, and they're sometimes called parent and child. So that's just something you have to memorize. That's just terminology. It's very generic terminology, like that makes sense, base and derived, or parent and child, like that parent child, one inherited from the other kind of thing. But you need both those classes for inheritance to work, because if you just had the base class, then nothing would be inheriting. If you just had the child class, it would have nothing to inherit from. So yeah, that's the terminology for that. There's two types of inheritance. So let's just do this thing that I talked about. So we have like class, vehicle, and then class, car, care. Yeah, same, care. And class, airplane, or just plane. Make it shorter. So the two types of inheritance we can do is public. I called it care again. Where did care come from? And private. So public inheritance, when you see that, like when you're just reading class creation, see public, you can think has a, not has, is a, sorry. Public is a relationship. So car is a, public vehicle. Car is a vehicle. Now, what I'm about to say for plane won't make sense, but just bear with me. So car is a vehicle. For private inheritance, you would say plane has a vehicle. There we go. So maybe plane is the best example of this. What has a vehicle?
A person.
Wonderful. Carrick gives me a person. So you can say a person has a vehicle. Just if whatever you're using, like you were trying to make maybe a game that was like a car racing game and there were people and they had a car or had a vehicle, then you could do something like this, a has a relationship. That's perfect. So both of them are inheritance. They're just the different kinds, and it limits what you can do with them. With the has a relationship, there's ways to access a specific vehicle object that is associated with the person, and you call it just like you would call a member variable. So the next thing on here is what concept is similar to private inheritance? That's like member variables. Honestly, I would probably just use member variables. There's probably some situations where private inheritance is better over member variables, but the has a relationship is very similar to member variables and the type of access you get with that. I guess technically protected information would be the benefit, but we'll go into that. So yeah, has a relationship is a relationship for public. I'm messing that up so much today. For public, it's an is a relationship. For private, it's a has a relationship. And then that's similar to member variables. Protected access, how is it different from private or public access? So let's do a couple of things in this base class. Let's do private. Let me back up. Private int a equals 0. So we now have a new word, protected, int b equals 1, and then public, int c equals 2. And so let's just look at this, the is a relationship real quick. If we did like car, constructor, and then here we did cout car.a, this dash a. And we should do the same thing. Oh. For B and C, we can see real quick what information you have access to here and what you don't. So you can kind of think about it just before we even run it. Private usually means that you can only access it inside this class, right? When you're only writing functions inside the vehicle class. Public means you can access it if you're making it in like main or something. And so protected is kind of a unique thing with inheritance, where if we run this, we'll see that the error only comes with me missing brackets. Semicolons. There we go, run that. So the error only comes with this right here, cout this A, because note, it was declared private right there on line 13. So if we comment out this one right here and run it, I need to actually make a car object. Car, there, that's fine. So with this, it should print out. I can't do that because this is not public. And the IDE would tell me all those things. It'd be so much nicer. There we go. So it prints out that 1 and 2 value. Kind of like if we had done the same exact thing down here. Now we'd get 2 errors with the A and the B. So it's A and B. Ooh, C's mad as well. Oh. Fair dot. So if we run that, we'll see that it should just be errors with A and B. So yeah, A and B, and they're telling me because they were initialized at the wrong protection level. So if we comment those out, now it's all good. So protected is like public, except it restricts it in main. So private, it can only be accessed inside the class that it was created in. So if it's private in vehicle, only vehicle can access it. If it's protected in vehicle, it can only be accessed by classes that inherit it. And then if it's public, it can be accessed wherever. Does that make sense? Okay. So yeah, right there, 1, 2, 2, and 1. And then remember, question. Concept of friendship and inheritance. And principal, private, and professional. That's good. So it looks like the keyword friend makes it accessible in other places. So duplicate.
He said not to worry about that.
Yeah, it's not in here anywhere. That's yeah. Thank you. But it looks like so friendship is a concept. You're correct, and it looks like it bypasses a lot of that kind of stuff.
Yeah, he said it's like only like a C++ concept, and then it's not like used very often.
Oh yeah, no, that's definitely. But yeah, so there it is right there for you. Carrick is saying that Fox said not to worry about it. So definitely don't need to worry about it, but it is a concept. You can play around with it if you'd like. And Carrick said supposedly Fox said it's only a C++ concept, so you don't have to worry about it, and that's probably true. So honestly, there's a lot of things that we've talked about that are just C++ concepts. That's okay. So I guess they're useful in other. Yeah, no, most everything we talked about is useful in other languages, even if it's not like a straightforward one. You just apply it. Whatever. So yeah, I'm not going to worry about the friendship stuff. But there you go. The private, protected, public. There's different places you have access to it. Oh, and here in vehicle, we can do vehicle. Just complete the whole trifecta. Let's add an extra endo, so we can see when everything gets declared. Run it. So you can see when the car class gets made, a constructor for the vehicle class gets called, because just like in programming 1, that super keyword, I know we explicitly said you couldn't make a default constructor for cow, and so like you had to use a super keyword. But here I was only using default constructor, so when I create a car, when I construct a car, the vehicle constructor is called for car, and so that calls this, and so I can print out all 3 of them. But then in the car class, I can only print out 2, and then outside I can only print out 1. So the whole chain of access. With private inheritance, you don't get access to protected anymore. So if we do person here, and also since it has a relationship, you're accessing a specific instance of the car object, the vehicle object, sorry. And the way you access it is like this, vehicle : So we would do cout vehicle : a, and L. Let me do this. B. C. Run it. Oh, and I didn't make a person. Does it want a semicolon there? Expected on line 40. I need this. Okay, what did someone type? I thought that private inheritance just made the public and protected class variables private and derived class. Yes, but it changes how you can access it as well. What that has is relationship. So yes, we're about to see what you're saying right here. We run this. There we go. So A doesn't get access to it, but right here, do that. Run it. This is fine. Let me make a person object instead. That's not gonna work. So we're gonna get rid of that because that's not, you can't access it outside of it like that. That's the whole point. Run. Lots of fun errors about access today. There we go. So here, this still gets called like normal, but then here to access those elements, oh my God, what did I just open? We do vehicle colon like that. And then I'm fairly certain there isn't a way to access it out here, and that's the whole point. Since it has a relationship, it's only inside. You can't just do like vehicle there. You can't just do like dot vehicle. You couldn't do something like that. So Nathan said, I thought that private inheritance just made the public and protected base class variables private in the derived class. No, it's no, it's different than that. That's not how, yeah, it changes how you have access to it, and then it changes how people with access to the object can have access to it. Like right here, like there's no, I don't at least know a way to print out this information. But you can see just right here, it's not private. You can still print it out. So that got printed out with the creation of a person object. And then you access it like that. So does that make sense how the private is? So you can't, with private, you can't access the inherited object out here. You can use it in here. If you disagree, I'd be happy to try some code. I could be wrong. Inheritance is definitely not my strong suit. I've never used outside of class environments.
I think I understand. So variable B and C are public and protected.
Yep.
And then A is private. So we don't have access to the private, but we can access B and C inside the derived class, but not in main because we have private inheritance. Those variables become private.
So he was trying to like walk through it again, and the only thing that was a little bit Nathan said when it's private inheritance, A, B, and C are still their private protected public, and so inside this class it's still private protected public, and so you still have access to public and protected, but then outside of here they're like private, all of them. It's not that they're just private out here, since there's no way to do this syntax as well. So yes, you can think about them as being private out here. That's a great way to think about it. But it's just there's also no way to do this syntax out here.
Got it.
It's not you can't just do var cout var dot c. Even though C is public, that's not a concept, yeah.
Yeah, okay, I see.
Okay. So that's protected access. We walked through all of those with the private and public inheritance. What is a constructor initializer list and how is it used? So what I've been writing here has all been defaultly constructed, right? I've never passed parameters around or anything. Well, the way you would actually call constructors in Java, there was the super keyword, but that's not how it's done here. So I'm going to do cout default. Let's make another one. Int A. So now one of them has parameters, one of them doesn't. With our current setup, I'm just going to get rid of that and that. And let's say now they only have an integer one, sure. Int A. Int A. With our current setup, I'm going to work with cars. No, none of that. When we run it, hopefully this works. Oh, car var 1. There we go. So when we run it, it calls the default constructor of the vehicle class, right? So to add the other constructors, we add the constructor initializer list. And the one thing I don't know, I didn't know if the other people, because I couldn't run things, is if it was colon or a comma. We're about to figure it out. Let's run that. Colon. Awesome. Okay. So to construct your inheritance stuff, you put a colon there. And so it's colon, and then you call the constructor you want to call, and then you pass in the information that you want to pass in. So in this case, I'm passing in A into the constructor for a vehicle, so it's calling this vehicle constructor. Does that make sense? The in-person people are just staring glazed-eyed at it, so I'm going to let them sit on it for a second. I got one nod. Okay, so that's how you can call all those constructors. There sometimes you have multiple things. So like, let's we do like int var1, sure. So you can also do actually let's just do like vehicle here. Vehicle var1. And so this is int. I'm gonna do int space A, sure. So there, and now here it's commas. I'm gonna do var1 A as well. Run this. There you go. So both here, and we'll make this +4. So if you have if you have member variables that could also be constructed, you can also use this constructor. You can use the, what is it called again? Constructor initializer list to construct all of your member variables as well. You do the variable and then brackets to pass in what the value is. So this is just a new way to construct member variables or inherited classes.
I have a question. So if you don't do this, then it's just gonna call the default for the inherited one for the like the inherited classes, like it's gonna call the default every time because you're not passing in like any parameter into it.
Yeah, Carrick asked if you don't use this, it'll just do the default one every time, and the answer is yes, that is what it would do.
Okay.
And I am trying, because I know, oh, it's right here. Speaker. Can you say something again, someone?
Hello.
There we go. Okay, so now I can hear their questions again, just so I don't go blank. Cool. Awesome. So yeah, that's how that works right there. That's the constructor initializer list. If we run this, everything gets constructed with the default values. Even the member variables if you don't do anything. Okay?
Okay.
So to constructor initializer list lists a list of all classes, and classes that inherit is sometimes referred to as what? Oh God, I don't. A tree? Someone? Sure. Inheritance tree. I could see something like that.
I think that's what he called it in lecture.
Or hierarchies.
Oh.
Right there. So yeah, hierarchies, they can get complex real fast. What is it called when a class inherits from more than one other class? Well, is it just multiple inheritance? I hate everything. Why is there a term for that? Like, why is someone like, man, what happens when it's inheriting multiple things? Multiple inheritance. Okay, so yeah, multiple inheritance. So that's just something you have to know. So multiple inheritance, hierarchy, class hierarchy, I think, what is it called? Inheritance hierarchies. Oh, love terminology. Yes, Java is specifically linear inheritance. Oh, and the multiple inheritance does create diamond problem. I'm assuming we're about to talk about it. Yeah. Oh, but it's not in here, which is weird. Diamond problem is usually like a fun one, because that's why you have to do virtual. Okay, whatever. So we're gonna say car, person, and then class unit. I don't think that's a keyword. I'm gonna say just public, just because I don't care. A unit is a person, and public car. So now with this, right here, we have the diamond problem is what it's called. Though I actually haven't made the diamond problem yet. Let's get rid of these constructors. Don't need them right now. That's fine. I'm gonna make it public. Void print info cout a and l. A, B, C. So right now what I've just done is I've created a function inside of the vehicle class. And that means when car inheritance, let's make everything public inheritance. So now a car is a vehicle and a person is a vehicle, just because I said person's a vehicle, sure. And so they both have this function now. Since they inherited it, now both car and person has this function. When a unit inherits from both of them, it has this function from both of them. That sounds weird, but what's going to cause is a redefinition error. So if we run this, I need a semicolon here, run it again. It's just default now. Delete, run it again. Come on, give me the error. Oh, semicolon. Stop giving me parse errors. Wait, why does the semicolon not stick? Semicolon, there we go. I get it, I'm shit at writing code. Give me the multiple definitions. Oh, it didn't. Oh, come on. Did I do it? No, void print in vehicle, print. What?
You actually have to call the
Are you saying I have to use things? I don't like it. Just print info. Print info. I want it just to compile and be bad. No, it just does it. What? No, there's supposed to be an issue here. Diamond problem. You want flying card, but unfortunately, the vehicle functionality twice. It looks like the solution is just shit all and nothing matters. Public, person, car, public, print info, class.
Does car also have to have that print info function though?
It shouldn't, no. Because it literally, honestly, I don't even think I need. Like, I don't even think I needed to define shit like that. I didn't even think I needed to define it. I think it's just, it should just be an error with the vehicle class. And flying functionality. Okay, well, that's not in the study guide, so don't worry about it then. Okay. What is polymorphism? Polymorphism is the concept of objects are multiple types of data. So in this case, if let's just get rid of unit. Person is both a person and a vehicle. Car is both a car and a vehicle. And technically everything inherits from the object class. So everything is an object. That might be Java specific. But just the concept that person could be the data type of person or the data type of vehicle. That is polymorphism, that they can be multiple things. A virtual function, what is a virtual function? A virtual function is a function that I put in here. And I do virtual void add and then equals. That might be pure virtual. That always fucks me up. Which one's which? Yeah, it's gonna ask me the difference between virtual and pure virtual. Inheritance is not my strong suit. But the concept of virtual function is saying this function doesn't exist in this class, but a base class, like a final class that needs to exist, has to define this somewhere. So this is saying this function needs to exist in one of my inherited classes. And so theoretically, with the diamond problem, if I had gotten that error to pop up, that was making it so that the function wasn't actually defined yet. It was just required to be defined at the end. So you only had the one definition of the function. That was what that was supposed to stop there. And then it's also, you could kind of think of it like const, where it's there to like force you to not change something or force you to do something. This also makes it so it forces you to write that. So if you forget to write that, that means you've done something wrong, because every class that inherited should have that. A good example of it would be like for shapes, which will be your next lab. There's a shape class, and then that says that every shape should have a function that is called display. So there's a virtual function called display. And then in that, what inherits that is 2D shape and 3D shape. And in 2D shape, there's a virtual function for area. So that means every function needs to have an area function. Every class needs to have an area function. And so finally, let's say you have like square that inherits 2D class, it needs to define display and area, because those would be unique to a square. So like for a square, your display might be like side length is X, and then area is X times X or something like that. But that kind of thing, where it's the functionality of those functions is different depending on the class. You're just saying that it has to exist. So that's conceptually what virtual is useful for, and then how it solves the diamond problem. Now, actually, how to write that? That's a great question. So yeah, abstract base class is involved with that as well. So that's virtual inheritance, but I'm looking for, that's all about that. I don't want that. Polymorphism. I've literally taught the same thing 2 years now, and I still always fuck up what it is. Because I know in Java, there's the concept of like, it's not, there's two different types, and one of them is that it had to have been defined in the parent one, and one of it's teaching programming 1 and 2 fucks me up in like their definitions. Okay, so virtual. Okay, yeah, okay, that makes sense, because then the equals the pure virtual means that, okay. Let me just implement that real quick. So virtual here, just add, we can do cout fun virtual. And then here we can do void add. Okay, we're good. We're on top virtual. Okay, so virtual function. So this is not pure virtual. Would be if you added an equals 0 there, and we'll get into that in a second. But virtual, it still means what I said. It means that a base class has to define this. But when it's not pure virtual, that means that this class is also defining it. And so where that would be useful is you're saying that someone could make a vehicle object. They could just make a plain vehicle object, and it has an add function. However, if a class inherits this, they have to define their own. So it's still that requirement that it needs to be defined, but it's saying that this class could have it by itself, or the inherited one has their own, which is different. So that's what this is talking about, like right here. So it's just each thing has to have a different behavior. So car has a virtual function, and it's defined, but then this truck that inherits it also has to define that function with its own behavior. Pure virtual functions, where's that?
Wait. So back to like normal virtual. So it's essentially saying that like if you want like two functions that are inheriting the same thing to have the same function but different functionality.
Mm-hmm. It's like right here, if we run this, should print out non-virtual, but we can do vehicle and run that, and then that's virtual. However, if this was pure virtual, that would be illegal. I don't even know if this is pure specifier on function definition. Oh, it's that. That's what you do. And so now this is illegal. So now that you have, once a class is a pure virtual function, you actually just can't initialize an object of that class anymore. It's only used in inheritance. So right here, I can't do that, but I could do car.
So it's sort of like having what is it called when you like define like you only have like the what is it called? Like if you have a function and you want to call it at any point, you can
Static.
No, like the little like without any of the definition, just like the
Abstract function?
no.
Yeah, in Java it's like abstract, and then there's one other word that I can't remember.
Does pure virtual also mean the abstract base class? Are those like when you have a pure virtual function, does that make the class that's in the abstract base class?
Yes, those two things, those two concepts are connected. Yes. So even right here, it's saying cannot declare variable var to be abstract type car. Car is an abstract type because it inherits vehicle, but has not defined this add function. So if there is a virtual function that has not been defined, it is an abstract class, and that's what abstract base class comes from. That's what that concept comes from. Yes. But Carrie, you were talking about virtual functions. You still like you were trying to verbalize something about that.
Yeah, it's not coming.
It's not coming. Okay, well, if you think about it later, feel free to bring it up.
Okay.
But so yeah, virtual functions is that concept where it has to be defined. So here, let's make this non-virtual. Let's not pure virtual, but so here, and then if we don't do that, this should give us an error. Because there's a virtual function. Oh, it called the virtual. What the frick? You think you know things. Hold on, I'm trying to Google it. I don't understand. I really don't. My mind is honestly going blank trying to comprehend why someone decided this was a functionality they wanted. I try to always back it up with something, and my mind is blanking.
So is this like if you had a car and a plane, which are both vehicles, and you wanted to call the same function for both of them, but you wanted them to have different functionality, but like
that's what. So pure virtual, we showed, is definitely the one I was thinking. Pure virtual makes this so that it's not defined there, and if you don't define it in the class, then it stays illegal to even have that class without this function being defined.
Okay.
So these have to have their own implementation, but there's something about not pure virtual that I need to wrap my head around. So the fuck is this? Print base class, show derived class, base pointer, drive D, print show. It did print for this one because it's virtual, and then derive for that one because it's not virtual. Because virtual definitely still has something to do with it's going to be defined later, but the fact, so what if it's not defined? Okay, I'm going to copy and paste this. Take this. So what if it's not defined later? Run this. So virtual is just saying it could be defined later. I don't like that.
Then what's the difference between like than a normal function then? Because can't you just override it?
Print base. Is there a concept of override in C++? I don't think there is. Maybe this is what that's trying to get around. But it looks to me like what virtual is saying that there could be a definition later that you should use. And non-virtual means don't even look for it. But then what if it wasn't a pointer? Why is the pointer concept so important? So what if it was just derived? I've scared Victoria out of the room. I'm making 0 sense.
You might need to change that to dot print or
Oh yeah, you're so right. But I don't like it if it has to be used with pointers. That rubs me the wrong way. Yeah, so both of these just print derived, but then if it's base equals derived, so you should be able to do this. That's base for both of them. I don't like that. I don't like that one bit. But yeah, it does look like it's something unique to pointers. So yeah, it looks like it's because override in Java is a concept, but that's not a thing here. So I guess.
You can override in C++. I just
Can you?
Yeah, it's kind of like a proofread for when you specifically want to override a virtual function. But since, like, let's say you mistype, the parameters for the function, so it's not an exact match.
It'll yell at you.
It'll let you know if you mention the function header that it's supposed to be an overridden function. It's you put override after the parentheses, I think. And then if you like put different parameters in for the show function, the compiler will say you meant to override this, but it's not. There's like no virtual function detected.
Hey, look at that. It doesn't have to be it looks like it doesn't have to be virtual because this could just looks like override is separate from virtual. No, look at that.
Maybe the parent function needs to be marked virtual for the override not to act up.
So override, and so you said it needs to be marked virtual. I fucking hate C++ with a burning passion. Okay. So we're proving, am not a great source for virtual stuff. I'm very sorry. Thank you, Victoria. You're so kind. But we definitely, the inheritance stuff, that's true. Polymorphism, just the concept of objects being multiple things, yes. Pure virtual, that one I do know, I promise, because that's connected to an abstract base class. So if you have a pure virtual function, that means it's not defined, and then until a class that inherits the virtual class, the abstract base class, defines that function, it is also an abstract base class. So that's definitely true. And then upcasting and downcasting is saying cast this so that it runs. Oh, hold on. This one I think I can show. We haven't talked about this at all yet. So void. I don't care about override. My homies hate override. There we go. So print base class, print derived class, print derived class. So here, if we do derived var, and then var dot print, and then var dot show, like we know how that's going to work. That's going to print the derived ones. There you go. But derived is still a base. So if we do base var dot print, this my brackets might be off. We're going to try this out real quick. I definitely forgot semicolons. So yeah, my brackets might be off. Let me just run this real quick just to see if it doesn't care. Error, invalid use of a void expression. Yeah, my brackets are off. There we go. There we go. There we go. So upcasting and downcasting is this concept. So this, oh god, which way is which? Upcasting is what I just did here. Downcasting would be if I did base var equals derived. That's legal. It should print out base for everything.
Wait, so upcasting is going towards base and downcasting is going down towards the derived?
Yeah. Think of it like the tree.
Okay.
And if I'm about to go check it too, but I'm just showing that it can, this is just showing that it can go both ways.
Wait, wouldn't it be the opposite? Because I said going up towards the base.
Upcasting is up towards the base. Derived is down towards the lower ones. Derived, hold on. In CUV function, it main no matching function call for derived base. This looks illegal. Upcasting allows you to treat derived classes if they were the base. So yeah, up the hierarchy. And then downcasting is treating like the base like the derived. It might only have to do with pointers then. So then in our case, it'd be base. There's hero and wizard, hero, wizard, and fighter. So base pointer special equals new derived. Then R hero equals. Oh god, dynamic. Yeah, downcasting is definitely not common as much, but this is conceptually this is downcasting. I don't think you ever even have to do it for a lab or anything. If you do, I'm sorry. But yeah, the concept of upcasting and downcasting. Remember the tree, the inheritance hierarchy.
Wait, sorry, one more time. Upcasting is going towards the base.
Yes.
Okay.
So just remember this inheritance hierarchy. While I can't pull that out of my ass all the time, just that terminology, I definitely like this is how you think of it. Oh, right. There. So you think about it like that. Where it just like you start at the base thing and then things inherit from that kind of thing, like a family tree. The family tree, I guess maybe I'm wrong about this, but most of the time when I see a family tree, the oldest person on top and they go down. Yes. So upcasting may be going up the family tree, downcasting is going down the family tree. Same concept here with parent and child. So I think the only thing I didn't explain very well is what a virtual function is. Hopefully. Any questions on that? I'd be happy to try to answer or tell you that I can't. Okay. All this stuff, you'll see the practicality, especially the pure virtual stuff. Like I said, you'll definitely need the pure virtual stuff, which is saying that it's not defined here, but it has to be defined in a derived class eventually. You'll see all of that in next week's lab, I think. Yes, lab 6, that's shapes. Yeah. So next week, you'll see a lot of that. Any questions about binary file IO for this week? Want me to go back and because okay, so big question, Victoria. How to do that? Yeah. So the question was creating an object inside an object. How do you do that? There's a couple ways, but just generally, let's get rid of all this stuff. So I'm going to get rid of the inherited stuff. I don't want to talk about it anymore, but if someone has a question, speak now for hold your peace. Okay, I'm deleting it. I hate inheritance, just conceptually. I'd rather write more code. So you'll have some sort of ship class. So the question was, should we make it a struct or a class? Does it not matter? It literally doesn't matter. The important part is that struct, all the stuff is inherently public. Class, everything is inherently private. That's the only difference, at least I know. So you have I just want class ships. Just class ship. And then in here, you'll have a vector of weapons. Call it like arsenal or something. And so to do this, or just a vector of weapon objects, that's better. To do this, you can either do just another class entirely, so class weapon, or if you decide that weapons are so associated with ships that they should be a nested class, you can do class weapon. But anything like that is fine. So kind of like nodes with linked lists, except now it's not a linked list, it's a vector. So pick one of these two. No problem. And yeah, they definitely can be structs. That's totally fine. All right, if there's no more questions about lab 5, I'm just going to quickly look at project 2. That's not what I want. Move everything out of the way. Image processing. Okay, so project 2. You look at this and you're like, oh my god, it's a 15-page document. Victoria just gave me, I don't have fucking time for that. Yeah. So it's a 15-page document. There is a lot of random bullshit in this. For some context, Fox, his background is in video games. And he made this thing. He was like, ooh, let's do a graphical thing. He is also the head of the DAS department, so like digital arts and sciences. So he has a lot of stuff in here explaining what you are actually doing to pixels and stuff. So like if you wanted to know why all this pixel manipulation stuff was happening and what's going on, you can read every single little bit about this if you want to. You can also just skim it once to get a general understanding, and that's also totally fine. You don't need to fully, like, you should, like a pixel, it's got red, green, and blue values. And then those values, honestly, you really just need to know that they're from 0 to 255. That's honestly enough just conceptually about pixels. You do need to know the order because that's important for reading in information. But there's a lot of stuff on here just about pixels and like what combinations of colors make certain pixels, and just that the concept of red, green, and blue can make every color possible. So if you've got some background knowledge about lights in general and understand conceptually what a pixel on a computer screen is, you'll be fine in that context. But there just is a lot of help because some people, they don't. Coming into this class, we don't expect you to know anything about that. So if you've never seen a pixel in your life, spoiler alert, they're on your laptop. If you've never seen a pixel in your life, then this can help you guide through all that context. So I'd say the really important parts of this, the parts that are like 100% important, just conceptually reading a binary file, you talk about that in here. Viewing a TGA file, this is important, just a one-time thing. You need something that can view a TGA file. I'm fairly certain Visual Studio Community does that. I personally use GIMP. Whatever you have to view TGA files, that's really useful for debugging. Because with image files, you can look at it and see whether it's kind of right or kind of wrong. Now, actually, in this project specifically, there is a lot of times where your values might be 0.5 off or like one value off, and you can't see that visually. You have to see that through code. So you'll also have to make tests that run through each byte of the file that could, oh, what this project is, I never even explained that. You're going to be reading in TGA files, most of the time 2 of them, and then doing some sort of calculations with the pixels in each. So like there's a multiply one, so you have to multiply the 2 pixel values together. So each red, each green, each blue, and then store that in a new thing. And then you'll have a new image. You'll write those pixels to a TGA file, and it'll be a completely new image. So that's what you're doing. So you need something to view those results to see that your mixes are good. Because there'll be something, do we show any examples? No. No, we don't show any examples here, but if you go into output, here we go. Oh, no. Examples, here we go. Do we have anything to view TGA files on here? LibreOffice, sure. Does this actually open TGA files? TGA are like official file types, by the way. Like this is something. Sure, there you go. You guys can see it there. So this, I'm fairly certain. Oh, you guys on Zoom can't see it. This, I'm fairly certain, is the blend. Actually, I opened example 1, so we can go to part 1, to task 1. So this is multiply. This is multiply between layer 1.tga and pattern 1.tga. So input layer 1, pattern 1. So the resulting thing we have is a combination of these 2 things being multiplied together. And there's a couple other different algorithms besides multiply. That's kind of the basic one. But if you do it and the visual you end up with doesn't even look close to this, you know you're doing something big wrong. There, like I said, there could be little pixels off that you need to still, like if you get little pixels off, the image is still incorrect and you get a 0 for that task. So you do need to go byte by byte to make sure that the image you make is the same values as this example image. But having some sort of TGA reader is good. That's just a one-time thing. You'll never have to worry about that again once you've got the one. Yeah. Okay, so overview, reading binary, viewing TGA files. Yep. File format, very important. This is kind of like any binary file. You're going to need a format to understand what order of information you're reading stuff in. So this is the order of information in a TGA file. A lot of this stuff in the file header is not important for this project. TGA files are an official file that people use to manipulate images and do shit with them, but we aren't doing everything that someone who actually does this for a living might want to do. The only thing that we care about from this is the image width and image height. Yes. Size, image ID field, nope, 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 nope. Yeah, image width and image height are literally all we care about from this. But you still have to read all of them and store them somewhere, because when you're writing them, you have to write all this information. And even though we don't care about what it is, you want to make sure that it's the standard one from at least one of the two images you loaded in, because as long as it's from one of them, then it's going to be valid information. Like both of them will have the same. The only time where it might be different is there's a time when two of the images have a weird size. And so you still just need to pick from one of the two, it doesn't matter. But all images are going to have the same, all this other info, except for height and width. Does that make sense? Question? Yes. So the question was, like, we're taking these two images, reading them, and so because they're binary files, so reading them as binary files, taking the data, which is the image data right here, and there is for each pixel, so this is image width, image height, you multiply that together, and that's how many pixels there are. For each pixel, there's 1 byte for red, green, and blue. So that's how much data there is. And you take each of those data, multiply it together, and then write it to a TGA file. Yes. You don't have to completely understand it at this point. I am just doing a general overview. So you don't understand like how you would do it, like how you would store the image, but just understand that's a concept. So yeah, you need a header file to store all the information. Again, nothing matters except for the width and height, but you still need to store it. Color data, the important part here is the order. So it's unsigned, use unsigned characters because byte value, pixel values go from 0 to 255. So that's really important. That's unsigned characters, the amount of data they can store. So yeah, 200 by 300 means it has 600,000 pixels, but then 3 bytes of data for each pixel, going like red, green, and blue. But important note that even though we talk about them as RGB, they're stored in reverse order. So the first byte is blue, the next is green, next is red. Now, when you're doing the multiply, since it's just multiplying all the information together, that doesn't really matter because it doesn't matter the order as long as you put it back in the same order you read it. But for some of the tasks that will matter. So you might be doing everything perfectly and not with that order, but just keep it in mind. So yeah, this is talking about what is a pixel. So if you generally understand that the 3 values come together to make the final thing, like you don't care about what it actually represents. You just care that it creates the right values. The images are just a supplement to help you see that. You're never going to have to like actually open up an image in Photoshop and like edit it. We're just working with data. Yes. Yes. So for every task, the question was, are the values that you want given to you? Yes. So we give you an input folder, which has all the inputs, and an output folder, which is where you should be writing your stuff to. And then SRC folder for your code should go. And then this examples folder is all the example from part 1, 2, 3, 4, 5. So like when you finally finish this whole project, you should have one file for each of these. Because there's like 10 tasks. And so there's 10 of these and then an extra credit task. So writing the file should be exactly the same as reading the file. Just instead of read, you do write. And then this gets actually into the image manipulation. So I'm not going to go over that. I'm going to say, since we're also at the end of the lab period, I'm going to say a good place to start, a good place to be next week is to get your reading and writing files and storing in whatever data structure done. So an image file has all this stuff. Read it in, store it in an object, and then write out the same stuff. So just you should take in, like, let's say you did layer 1. You should be able to read in layer1.tga and then write it to like just whatever file name you want it to. So just make a new one called like test.tga. So just read in layer1.tga, write a file.test.tga, and have it be the same image. That is a great place to start. Because if you get that done, then everything is just data. And that is a good place to be after 1 week. Like that's something that people still struggle with. So that is what I recommend for project 2 by next week. How you do that might be a little confusing, but there's no manipulation involved with that. You could honestly, you could, I would say even if you don't have a data structure, it'd probably still be good. So if you read 1 byte, you read bytes up to image width, store image width, store image height, and then read 2 more bytes, and then read all of the bytes in here, and then just write bytes in the exact same order, just conceptually understanding that, that would be a great place too. So not even using a data structure. So maybe start without a data structure, just like hard coding, reading 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 bytes, and then reading width, height, and then read 2 more bytes, and then have a vector of bytes that reads image width times height times 3, just reading that many bytes, and then writing them in the same order to that test.tga. That would be a great place to start. Okay. Did we ever go over write? Write looks exactly like read. Yeah, so if I had OF stream test and then test dot text and then iOS base binary and then test int x equals 4, you would just do test dot write character pointer address of x comma 4, and that would write 4 bytes to this new file test.txt. I wonder if it would even yes. So right here I could do 70, sure. Sorry. Variable standard OF stream test. Oh. Hashtag include OF stream. Okay, so this would usually create the file. I think just with what I'm using, it doesn't create files, but this right here, try that at home. That should write that. So you should be able to write this, and then if you wanted to read it, you should get 70 as well. Does that make sense? So then just the key thing with here, just make sure you read and write in the same order. Oh, I already closed it. And now I'm 5 minutes overlap. I'm so sorry. Go to wherever you need to go next. This is recorded. I'll post this. I also need to go fix a computer. Thanks. Carrick, Abigail, have a wonderful rest of your day as well.
Thank you.
No problem. Okay. Bit of a hard drive. I don't know.
You know what I mean? Like, what, like files on those things?
It really, like, it's really slow, and then when I was trying to do some code stuff, just even like opening Visual Studio Community, it just crashed. And I tried restarting it, I tried restoring it to a thing. The last thing I tried to do was do a full scan, but the full scan said it was going to take 35 hours, and I let it go for a while, and it still said that, so I think it actually might take 35 hours. So for now, I'm just going to keep it isolated. I put a USB stick that was mine that shouldn't have anything on it, so I'll keep that isolated as well, just in case that was the issue.
Do you have all your files like backed up?
I have the important ones backed up.
Oh, okay. Might just have to like restore Windows. I feel like you just have to do that on every laptop. Like Windows is just.
You're probably right. That's what I'm gonna have to end up doing. See you, tutorials. Also, is it Matthew or Matt? Oh, your name is Matthew, but you go by Matt?
Yeah.
Matt then.
Okay.
It's,
So I see.
by Matt.